Okay, so today I will teach you one of the important topic of quantum mechanics. That is Compton effect. So this phenomena or this subject is belongs to your courses, that is called modern physics. So first of all, we know that photoelectric effect, right? So what is photoelectric effect? We have learned that when photon falls on a material, then electron ejects. So this phenomenon is called photoelectric effect. And why this is important? Because this phenomenon clearly contradicts our classical theory of physics. So what is classical theory? The classical theory tells that light is an electromagnetic wave. Now this phenomenon, photoelectric effect, does not support it, and we know that there is another type of suggestion which gives and which comes from the Planck's hypothesis, which is called that we cannot only think that light is only electromagnetic wave, but also it has some particle nature. And this suggestion comes from Einstein photoelectric relation. That is, if we consider that light which has some frequency of nu and its energy can be h nu, it falls on the material, then it divided into the two parts. The first part is that the work function, and another is the kinetic energy of the electron which ejects in this material, from this material. Now why this is important? Because the quantum mechanics which gives the suggestion that light is not only the electromagnetic wave, but it has also some particle nature. So it can be both, either wave or particle. So what is the example of the wave? Example? Okay, tell me. Interference. Diffraction. Yes. And the particle nature, photoelectric effect. And another example today we learn, that is Compton effect. Okay, so now the question is, what is quantum effect? So when an electron on the photon source falls on a material, then when this is scattered into the two parts, that is the electrons goes into the in one way and the photon goes into the another way. But the important part is that this frequency and this frequency of this photon are not same. So this is h nu dash. So first, the photon falls on a material, it interacts with the electron, and when this photon is scattered, it has some other frequency rather than h nu. Okay, so this is contradict with the classical theory. So there should be some wavelength or frequency difference between these two, h nu and h nu dash, right? So this is called Compton difference. Compton wavelength difference, that is nu minus nu dash. Again, let's understand what is the difference between this photoelectric effect and this quantum effect. So what happens in this photoelectric effect? Photon falls on the material and electron scattered. So there is no way of scattering of these photons. Okay. But in this Compton effect, and we will learn also that what is the main difference between these two effects. But before this, let's understand this quantum effect simply by simply that this H when fall on the material, then the electrons have some kinetic energy, but this photon was also scattered by this electrons, and the frequency of this scattered photon is different from this incident photon, and this difference is called the Compton difference. Now, why this cannot be explained classically? What's happened? Because when it's interact with the electron, then it oscillate. Okay, so when X-ray or any other ray which has some photon is falls on the material, then it oscillates with the same frequency of this frequency. Then while it will radiate, then it will go into the h nu, which explain the classical theory. But what we have observed, that this is different from this frequency h nu dash. Okay, so and what experimentally you can prove? Experimentally, if you observe that suppose there is some source of X-ray which falls on a material, it is graphite, let's say, it is source X-ray, and there is some collimators which guards the unwanted rays. When it falls on the material, and there is some detector here which detects the scattered X-ray. Now we can find that if we plot the intensity with phi, suppose intensity I, then if this is lambda, then at phi equal to 0, only one wavelength you can find. But when phi equal to 45 degree or 90 degree, then you will find these two wavelengths. This is lambda dashed associated with nu dashed, and this is lambda. Now what is our job? We have to find out the difference between this lambda dashed minus lambda. This is Compton wavelength difference. Till now any question? কোনো কোশ্চেন আছে বলো, বা যদি কিছু অসুবিধা হয়? Wavelength যদি difference করি, if we do the difference between the wavelength, then this is lambda dash minus lambda, and this is frequency difference. If we consider the wavelength difference, then this is lambda dash minus lambda. So this is experimental observation that when X-ray falls on a graphite and if we detect the scattered wavelength, then we can find this type of intensity distribution. Like at phi equal to 0, phi means this angle and this is theta. This is the both theta. Then when phi equal to 0, there is no wavelength difference. But if we increase the phi, then we'll find that there is two type of wavelength, lambda and lambda dash, and this follows some patterns, and we'll prove the pattern which should be equal or consistent with the experiment. So let's do one by one. So this is our incident photon, h nu. This is a scattered photon, incident. This is scattered. This is the electron with some kinetic energy which interacts with the incident photon. So first we will apply the energy conservation law. Energy conservation law. So this energy should be same of these two energy. Okay. So here the energy how much? Incident of the incident photon? H nu. And the scattered photon how much? H nu dashed. And what is the energy of this electron? Kinetic energy of this electron? So here H nu should be equal to H nu dashed plus how much? Ek, if we say that the kinetic energy, then we know from the special theory of relativity that this kinetic energy should be mc square minus m naught c square. right? So this is m c square minus m naught c square. Okay. Now recur to H nu dash. From the relativity, what we can write this m as m equal to m0 by root over of 1 minus v square by c square, right? If we say v by c as beta, then m equal to m0 root over of 1 minus beta square. So m naught c square by root over of 1 minus beta square minus m naught c square. Okay, till now any question? বলো, কোনো কোশ্চেন থাকলে বলো। কোনো যদি কোশ্চেন থাকে বলো। বোঝা গেছে দেবজ্যোতি? বোঝা গেছে? আচ্ছা, next we apply the momentum conservation law. Okay, so here how much the momentum? H by lambda. P is equal to H by lambda. Okay, so from this energy conservation, and momentum conservation, for both parallel and perpendicular direction, and doing some small calculation, what we have got that lambda dash minus lambda equal to h by m naught c on minus cos phi. Okay, so this lambda dash is the scattered wavelength. So what was the picture? The picture was, so X-ray wavelength fall into the electron, interacts with the electron, and there is some scattered X-ray photon which has some wavelength of lambda dash, and this is lambda and this is the electron. So there is some difference of this wavelength, that is lambda dash minus lambda equal to h by m naught c on minus cos phi. Okay, so this difference is called Compton shift. Okay, so it does not depends on any other thing other than this phi, because this thing are constant. H, m naught c. H is the Planck constant, m naught is the mass of the electron, which is fixed, is the velocity of light, fixed. So only depends on the phi. Okay, so what was the experimental observation? The experimental observation was that the intensity of this the detector is like this. So this is for phi equal to 0, where only one lambda we have got, right? So we have shown earlier. So here just put phi equal to 0. Phi equal to 0 means cos phi how much? Cos phi equal to 0. Then cos phi is 1. So lambda dash minus lambda equal to 0, because 1 minus 1 is 0, and then lambda dash equal to lambda. So there is no other wavelength other than this lambda. But if we just increase the phi, then it will divide into the two parts. So this is suppose lambda, and this is lambda dash. This is phi equal to 90 degree. In this way you can increase and you can get how much will be this composite, that is lambda dash minus lambda. Okay, now it is consistent with the experiment. So this theory supports that the particle nature of this photon, so just like the photoelectric effect. Okay, now there may be some problem where you have to calculate like some kinetic energy of this electron. How much is the kinetic energy? So if you get this lambda dashed from this picture, then you can calculate the energy of this photon, that is c by lambda dash, right? Energy of this scattered photon. Then how much is the kinetic energy of the electron? Kinetic energy of the electron is Ek, suppose this is h nu minus h nu dash. That means hc by lambda minus hc by lambda dash. This is energy of the scattered photon, and this is the kinetic energy of the electron. Still now any question? কোনো কোশ্চেন আছে? বলো।